Alrighty, we're going to start doing the 5A notes. We're going to do about the first 2 pages. I know I always put extra spaces in mine so I can write extra, but I'm going to do half the note, so hopefully just 2 parts in 5A. The point with the coordinate 0, 0 is called the origin. It's right dead center in the thing. If I were to draw a little graph here, that's the origin. It's right there in the middle. A point where the graph crosses the y-axis is called a y-intercept. And we will be doing lots and lots of those. Like if I had a graph here, that's the y-intercept. And a graph where it crosses the x-axis is called the x-intercept. So the x-intercept would be right there, the y-intercept would be right there. The graph of y equals b is a horizontal line. So horizontal is this way, and the graph is a vertical. Vertical is straight up and down. So anytime you see x equals something, you know it's vertical. So you just draw straight up and down. Horizontal, y equals horizontal, just draw that. And we'll do several of these and you'll get it. You'll just have to memorize that. And the next one, a very important concept that will be dealt with a lot, is the slope of a line is the change in y values divided by the change in x values. There are many different versions of this. The true slope formula, if we're given 2 points, is just m equals y2 minus y1 and x2 minus x1. We'll do that in the second part of this section. It's also described as rise over run. And we'll really talk a little bit about this section, but 5B will do a lot of it. Now, change of y over change of x, or delta y over delta x, that's more of a calculus theme, but this is all the same. All right, so we're going to first review graphing points. Just do some basic graphing of points. Now, if you remember, these are always in x, comma, y format here. So if I go x is -2, so that means I go 1, 2, and I'm right here at -2, then I go up 4 because it's the y value. 1, 2, 3, 4. And that is -2, comma 4. When I go 0, 3, that means x is 0, so I don't go left or right. I just stay at the origin, and I go up 3. 1, 2, 3. There's 0, 3. And that's also the y-intercept because it's on the y-axis. If I do -2, 0, my x value is -2, so I go to where x is -2, and then it's 0 is my y value, so I just stay right there. So now this would be the x-intercept. If I plot 3, 2, I go over 3, 1, 2, 3, then I go up 2. There's 3, comma 2. If I do 5, -3, that means I have to go over to where x is 5. 1, 2, 3, 4, 5, and then down 3. 1, 2, 3. There's 5, -3. And the last one, -4, -2. So I go backwards 4 to get to 1, 2, 3, 4. Where x is -4, then I go down 2, plot that. That's -4, -2. There'll be a couple questions where you just got to label some points. All right, the next one. Is 0, 5 a solution for this equation? Now remember, the first one is x, the second one is y. So I'm literally just going to, we used to just put one value in. Now we're going to put 2 values and see if it gives us a true statement. Since x is 0, I'm going to do 5 times 0 minus y is 5, so it's 3 times 5. And the question is, does it equal 15? 5 times 0 is 0 minus 15. So that's -15. Does that equal 15? The answer is no. So that is not a solution. Again, this is x, this is y. So let's do 4 times 2 plus 3 times 5. Does it equal 23? Well, we get 8 plus 15. 8 plus 15 is 23. So 23 does equal 23. So this is yes. This is a solution. My throat is dry. All right, now to the hard stuff here. This is not too bad, but I don't like the way the book does this. The computer picks some very bizarre numbers. I have a way, this inset box right here, this is really how I want you to do it. The first step is always to solve for the letter y. Now, a lot of the times the y will already be solved for. In this case, it is not. But if I have negative 3x plus y equals 3, in Unit 4 we learned how to solve for a specific letter. So I'm trying to get y by itself, so I want to move the negative 3x to the other side. Well, what's opposite of that? Well, I'm going to add 3x because I'm going to the other side. Now, if you notice, I'm going to do this a little strange, but you'll get used to this. And it's y equals, you always want the x term first, so I always write 3x plus 3. We're going to make more of a thing about, we want it in y equals mx plus b format, and in 5b we'll do a lot of that. And we'll introduce it here. So now, I have my equation. It's solved for y. So what I really want to do is I want to make a little chart. And the book does a nice job of this. But then they pick some weird numbers. Always pick 0 as your first number. Because 0 is one of the great numbers here. When I put it in 3 times 0 plus 3, well, 3 times 0 is super easy. It's gone. So my answer is 3. And this is also, when x equals 0, this also happens to be the y-intercept. When x equals 0, that is always the y-intercept. Now, if no fraction, evaluate, the second value is the number 1. 3x plus 3 has no fraction, so I'm going to do 1. So it'll be 3 times 1 plus 3. Now, 3 times 1, almost as easy multiplying by 0. 3 times 1 is 3, 3 plus 3 is 6, so my second point is this. So, when I graph this, I have 2 points right now. 0, 3, 1, 6. I plot my first one, which is the y-intercept, go 0, 1, 2, 3, plot it. 1, 6, go 1, 5, 6, plot it. And there's my line. Now, I will create a separate video on how to use the graphing tool. I'm going to have to add that on here. If there is a fraction, we will do that in the next one. Okay, and then here, plot both points on the graph. The y-intercept is the point you've added, 0, 3. When you do it, the question after you graph it, there will be a question asking what's the y-intercept. Like I said, I will do one of those. Alrighty, so now we have another one. We have x plus 2y equals negative 6. Now, this is not solved for y. So if I want to solve for y, the first thing I do is get rid of the x. So I'm going to subtract the x over here. I get 2y equals negative x minus 6. Again, I put the x first. What's the opposite of multiplying by 2? Well, I'm going to divide everything by 2. So we get y equals. Now we have to remember, in front of that x, there's really an invisible 1. So that's really negative 1/2 x. 6 divided by 2 is 3. Okay. Now, if I do my little chart here, got x and y. Again, 0 is my first choice. If I put it in here, negative 1/2 times 0 minus 3. Well, anything times 0 is 0, minus 3, there it is. Now, if you look back up here, it says if there is a fraction, choose the denominator. So, what's the denominator here? Well, the denominator is a 2. So I'm going to put 2 there, so it's really negative 1/2 times 2 minus 3. Now, please use your calculator to calculate this out. But the reason why I picked 2 is because 2's cancel here. Negative 1 minus 3 is negative 4. But with all the negative signs, I would advise you to use your calculator just to make extra sure. Too many silly sign errors get people. So, I got to graph these 2 points, 0, negative 3. So, start at the origin, go down 3, 1, 2, 3. And you'll notice that is the y-intercept again. And I got to do 2, negative 4. Go over 2, 4. And there's my other line. And the y-intercept is 0, negative 3. All right. Now I'm going to use the same graph paper to do another one. This question baffles people. They'll give you y equals negative x, and sometimes they'll give you y equals x. It's almost too easy for people. It's already solved for y, so I don't have to do anything with that. The first number is always 0. So if y equals negative x, y equals negative 0. Now there's no such thing as positive or negative 0. 0 is 0. So we just plot the 0 there. Now, the next point is there is no fraction, so I'm going to do 1. So y equals negative 1. Well, that's my answer, 0, negative 1. So I'm going to do 0, 0 is my first point. Do this in purple. And then 1, negative 1. So I go over 1, down 1. And then I plot my graph, and there it goes. Alrighty, and so if you do notice, both of these slopes were negative, and they're both going down to the right. Now, if I look at this first slope, this 3, which is the slope, is positive, and it's going up to the right. We'll talk more about that in the last part of this, because we're going to talk about slope. Alrighty, and so this question gets people very nervous. There's a question very similar to this. It's really not a bad question at all. People ask it, we'll go over it, but it is a long question, so people get a little panic, and it's a word problem. So if 1920 we let t equals 0, and 1928 we let t equals 8, so it looks like how many years after 1920 is what we're going to allow. 1920, it's no years have passed, so it's 0. In 28, 8 years have passed, that's why it's t equals 8. So in 1937, we're going to let t equals 17, because 1937 is 17 years after 1920. So, what's the predicted record for the year 1920? Well, for 1920, we let t equals 0. So now I have this formula here. I'm going to just do negative 0.01 times 0 plus 45.5. But again, anything times 0 is great. It's just gone, so my answer is 45.5. What is the predicted year for 1932? Well, 1932 is 12 years after 1920, so that means t equals 12. So I'm just going to type in negative 0.01 times 12 plus 45.5. And you do this on a calculator and you get 45.38. Please stop and make sure you can type that in. In 1967, well, 67 is 47 years after 1920, so t equals 47. So I'm just going to type negative 0.01 times 47 plus 45.5. And type that on the calculator and you get 45.03. Now, this last question is slightly different. This time it gives me the time, not the year. So what that means is 44.92 is equal to negative 0.01 t plus 45.5. So now I have to find out what t is. So I got to subtract 45.5 from each side. And I do that, and I get negative 0.58 equals negative 0.01 t. Divide each side by negative 0.01, and I get 58 equals t. Now, a lot of people will type in 58 as the answer, but remember, that's 1920 plus the 58 years, so it's really 1978. Alrighty, and so that's the first part of 5A. Just about almost 14 minutes, so that's a good amount of time. And I'm going to stop this now.